Hi, my name is Derek, and today I'll be talking about my low-cost motorized transition microscope stage for confocal applications. So, have you ever wondered, what is the cost of purchasing a microscope? Well, what about adding an automated microscope stage? What's the additional cost of it? Well, what about the calibration, the tools needed to calibrate the system? What is the additional cost of it? Must cost a lot. Well, in the tens of thousands. Let's not talk about service charge. Imagine this. All of this in just a fraction of the cost. In just 1,000 ringgit? You don't need to imagine anymore. This is what I created. A low-cost motorized transition microscope stage integrated with an interferometry for calibration and a confocal microscopy. So let's get started. The stage that we utilize today is the open source open flexure delta stage. The cost of manufacturing one is at its 150 ringgit or even lesser. It is affordable, it is portable, but for its reliability, there is not much research done for the measurement in nanoscale. When we're using this in microscope alone, a calibration slide can be sufficient enough to quickly do the calibration. Well, however, for optic application, nanometer discrepancy can cause huge effect on the project itself. Therefore, interferometry is employed as it is sensitive enough to detect nanoscale movement. By utilizing 3D printed for interferometry parts, the experiment setup can be cost-effective and guidelines can be designed to assist in the alignment process. So this is the experimental setup, which this is the laser, this is the beam splitter, this is the non-movable gimbal mount, this is the movable gimbal mount, which is located above the open flexure delta stage, and outwards will be the screen. Next will be the showcase of the path of the laser travel. As we can see from this image, the beam starts propagating out and hitting towards the beam splitter. It then converts 50-50% towards the 2 gimbal mount and start propagating out towards the end of the white screen. This is a live demonstration for the interferometry fringes moving. Once we key in the value into the motor, we can see that the fringes starts moving, as seen here, and this is all captured in a slow motion camera. So this is the tabulated results from step 5 to step 10. We can see that from 5 to 8, the fringes are one movement, 315 nanometers. Once it reached to 9, it has a slight increase, and once it's reached to 10 steps, we can see that there is 2 fringes movement, which is 630 nanometers movement. Anything before 5 steps, we observe that there is not much movement to no movement at all. But for anything beyond 10 steps, we can see that the blurring effect starts to happen. As you can see around here, blurring effect starts to happen, rendering the result capturing to be sometimes impossible. So this is the setup for the confocal, whereby here is the laser, here would be the beam splitter, and right here would be the microscope objective. And we can see on my hand, here is the specimen that we will be scanning through. It will be placed right here on the motorized transition microscope stage on the open flexure, and the beam will go back towards the focusing lens into a pinhole of 100 microns and into the detector, light detector. And it is all routed into the Arduino and sent into the computer for data analysis. So this is the result of the confocal. The distance between these two peaks are 900 steps. The distance of gap that we collected is 56.7 microns. So for the benchmark, we will be using this, the Nikon Eclipse LV150N. Wow! The value that we collected is 56.8 microns. Do you remember how much we get for the confocal? It is not that far, just 10 microns. With a mere setup of just 1,000 ringgit, we will be able to acquire a low-cost motorized transition microscope stage with interferometry and a confocal microscopy, whereby if anything is broken in the process, repairing is easy as 3D printed part can be printed instantaneously. They say time is money. Now I offer you best of both worlds. Why pick one when you can have two? You can have it in faster time at a cheaper cost. Thank you for watching.